All right, so we've talked about one-step equations, we've talked about two-step equations, or multiple-step equations. Now we're going to talk about what have variables on both sides of the equation. So, general philosophy, just be organized here. If you have variables on both sides of the equations, use the inverse, well, you simplify first. Simplify one side before you start moving things from around. And then use the inverse operations to collect the variables on one side. So you simplify if something can be simplified on one side or the other, and then you need to get the variables on the same side of the equation. We need to collect the variables, and then we collect the constant terms on the other side, isolate the variables. So then we just solve like normal. So here we go. We've got 10 minus 4x equals negative 9x. First thought, can I simplify one side? Can I simplify this? Are these like terms, any distribution? Nope, nothing going on there. Okay, can I simplify this? No, just one term. So I'm gonna rewrite this real quick so it's a little easier to see as you write it in your notes. So now I'm thinking I need to collect the variables on the same side of the equation. I need to get all the variables on the same side. Do I want to get all the variables on the left? Again, reminder, when we say left and right, the equation, the equal sign is our middle. Okay. Do I want to get all the variables on the left? I really don't like the zero here. We'll talk about that. Zero's a number. It's not bad. It does happen sometimes, but it would make a whole lot more sense to collect the variables on the right-hand side of this equation. So now, minus 4x plus 4x, that's a zero pair, so I am left with 10 equals negative 9x plus 4x minus 5x. Now I can solve the equation like normal with my inverse operations. Divide by negative 5 gives me negative 2 equals x. Done. I can plug it back in and check the solution. Not going to work through that right now. We've done a number of checks in the last couple of days. So, problem number 2. Again, let me rewrite it. As you write it in your notes. First thought, can I simplify one side of the equation? Well, yeah, parentheses. First thing that pops in your mind when you think parentheses is you should be thinking distribution. That should be the first thing popping in your mind when you see all these parentheses here. So I am distributing my 3. That gives me 9x minus 12. Distribute the 1/4. Get out that calculator. Boop, boop, boop. 1/4 times 32 is 8x plus 1/4 times 56. 1/4 times 56, 16? 16? 14. 14. I think. Yep, 14. Now I need to collect all the variables on the same side. Me personally, I love, if I have variables on both sides and everything, there's stuff on both sides, I like getting the variable on the left-hand side. You may have heard about some little things. You want to pick on the little guy. You want to move the littlest one to the right or to the left. I'm not real picky about it. Whenever I do examples up here, you're always going to see me, if I can. Now the previous example is a little bit different, but if I have some flexibility, I'm always going to move the variables to the left-hand side. Okay, I'll explain that more when we get to chapter 2, but that's my preference. I don't care if you put the variables on the right-hand side and you're not going to get killed for it. My preference, variables on the left. So I'm going to collect all my variables on the left-hand side. 9x minus 8x is 1x. Do you have to write the 1? No, you don't have to write the 1. Okay, so now add 12, I've got x equals 26, answer. If I want to check this, I'm going to take 26, plug it back into both x's, and check and see if it works out to be the same. All right. Questions? No? All right. Let's do another one of these. I'm going to do number 2 here. So again, can I simplify one side of the equation? Sure can. I've got some distribution here. So I am thinking distribute by 1/2. That gives me 3h minus 2. Again, in my head, I want to get my variables on the left-hand side. So I am going to add 5h here because I need to get that to 0. I need my 0 pair, so that's going to give me 8h minus 2 equals 1. Again, get 8h equals 3. 5. H equals 3/8. I like fraction answers. I know most of you cringe with fraction answers. If you put this into a calculator, you get 3.3. Excuse me. 375. If you put that into a calculator. Fractions, I like fraction answers. So, you don't like that answer, you're not quite sure if that's the right one, you go back up to the top and you plug in 3/8 into h on both sides of the equation to see if you did it correctly. Questions, comments, or issues? So, again, we're going to get into some of these when there's variables on both sides of the equation. It is possible that you could have infinitely many solutions, and it is possible that something has no solution. So let's take a look at some of those examples here. All right. So, can I simplify? Yes, I always wanted to look to simplify. If I can gather your variables, collect your variables on the same side of the equation. I can move this over here, I can move this over here. So 15x minus 15x is 0 pair. 15x minus 15x is 0. I've got 6 equals 0 here. So, what happened? Where'd the variables go? 15 minus 15 is 0. 0, don't write 0x. 15 minus 15 is 0, it's 0. You got a problem, there's no variables left, okay? When this happens, if there are no variables left in your problem, then you go back, you've got one of these two situations. You either have infinitely many solutions or no solutions. By the way, you should write these words in your notes if you haven't done so already. Pause the video if you need to. If the resulting equation is false, then your answer is no solution. Okay? What that means is there is no possible solution to this equation. So let's pause for a second. What is an answer? What is a solution to the equation? A solution to an equation means this is the only number that I could plug back into this problem to make it true. The infinite number of numbers in the universe, this is the only one that works. If I look at this equation, 26 is the only number in the entire universe that will make this equation true. So when we get here, what we have found is that there are no numbers in the entire universe that are going to work here. None. I can plug numbers in all day long. None of them will work. There are no solutions to this problem. Conversely, if I look at a problem like this, again, start by simplifying one side of the equation. Collect your variables. Negative 8y plus 8y is a 0 pair, 0 pair. Now these two numbers are the same. So what does that mean? means there are infinite solutions. So in this situation where you come up with the variables to be the same and you have a true statement at the end, that means everything works. Every number in the entire universe will plug in for y here and be true. It will work. Pick a number, plug it in, it'll work out to be the same. So that's the exact opposite of what's going on over here. So again, if you evaluate this, this is only happening when the variables are gone. If there's still a variable, if this would be 15x minus 14x, not happening here, not a problem. Only when the variables are gone from both sides of the equation do we have one of these two situations. If the resulting equation is false, you say no solution. If the resulting equation is true, you say infinite solutions. All right, I do want to tackle one word problem, okay? So, boat travels upstream of the Mississippi River for 3.5 hours. So I've got Mississippi River, I've got a boat going upstream on Mississippi River. Time is 3.5. What do we not know? Well, we don't know how far, distance, and we don't know how fast, rate. The return trip takes 2.5 hours, so boat going on the return trip, 2.5 hours, so time 2.5, because the boat travels 2 miles an hour faster downstream due to the current. So the current is helping push the boat down the stream. So I don't know what the rate is here. That's unknown. So we're just going to call that R. But I know that the rate over here is 2 faster. Still don't know the distance. But I've got rate is my unknown, and time is 3.5. My rate is unknown, but it's 2 more than that one. My time is 2.5. So, how am I going to solve this? I've got all things I don't know. I still don't know distance. Well, in this problem, the boat, since it's the return trip, we know the distances are the same. So in this problem over here, we have D equals RT. So D equals R plus 2 times 2.5. Over here, we have D equals RT. So D equals R times 3.5. But we know that the boats traveled the same distance because they went up the river and then back down the river the same distance. So that means that the distances are the same, that I can take this and set them equal to each other because they went the same distance. So I've got 2.5 R plus 2 equals 3.5 R. So now we have variables on both sides. I see some distribution that needs to be taken care of. I subtract, I get 5 equals R. So how far does the boat travel upstream? This tells me the rate when it was going upstream is 5. The rate downstream would be 7. And it wants to know how far did it go upstream. So I go back again, D equals RT. So distance is 3.5 times 5. Distance is 17.5 miles. 3.5 hours, 5 miles an hour. 17.5 miles. So, again, a word problem. Notice I didn't just jump into writing equations. I started with a nice diagram, organized the information that I knew. Distance, rate, time. Distance, rate, time. I still didn't have something I could solve. I just had this equation and this equation. And then the connection is that the distances are the same, so then we can set the two distances together, solve the equation, plug it back in to find the final answer. All right. Can't wait to see you guys on Thursday. Take care.